Our next topic in this section is what's called quadratic forms. So we're going to be solving equations that may look a little more complicated than they actually end up being. These are equations that we can manipulate and use our quadratic solution techniques, but that are not exactly quadratic themselves. So an example of that might be the equation x to the fourth minus 6x squared plus 8 equals 0. So the pattern here, if we would like to determine if something is a quadratic form, do we have a version of a variable, and do we have that variable squared? So if I think of x to the fourth, I could think of this as x squared squared So really, here I have something squared minus 6 something plus 8. Our general approach here is to replace or substitute a single letter, usually u, for whatever that something is. Okay? So if I go back to this equation and I think of this as u squared minus 6 times u plus 8 equals 0, then we see that we are dealing with something that is basically quadratic in form and can be dealt with using our quadratic techniques. We can begin by trying to factor. If that doesn't work, we might try the square root method. Failing that, we can use completing the square or the quadratic formula to solve for u. Alright. So I'm noticing that this appears to be easily factored. We could factor this as u and u, and then I need numbers that multiply to 8 but which add up to negative 6. So off to the side, we could do 8 as 1 and 8, negative 1 and negative 8, 2 and 4, negative 2 and negative 4, and I think that last pair is our winners. So minus 2, minus 4, and that's our factorization. So now we can solve for u. U is going to be positive 2, or u is going to be positive 4. Well, we're almost done. We don't actually care so much about what u is. This is just an intermediate process. Going back to our original statement, we want to know what x is. But x and u are related in this way. U is just x squared, so we substitute that value back in. So x squared is actually what's equal to 2. Or x squared is actually equal to 4. And then we solve for x. I would say we unsubstitute. Okay. Well, both of these can be solved using the square root method. If I root both sides of this equation, I get x equals positive or negative root 2. And if I root both sides of this equation, I get x equals positive or negative root 4, or positive or negative 2. So we come up with 4 solutions to this equation. X equals positive or negative square root of 2, and positive or negative 2. So let's check our solutions. Checking is not as essential in this particular type of equation as it was in the radical equations, but it's never a bad idea. You know, we could always make mistakes, so you always want to check your work. Okay, and I will check x equals the square root of 2 first. Well, if I plug that into my equation, square root of 2 to the fourth minus 6 times the square root of 2 squared plus 8. If I raise the square root of 2 to the 4th, I can think of that as the square root of 2 squared squared. In other words, 2 squared, which would give me 4. Our square and our radical cancel here, and we get minus 6 times 2 plus 8. So that's 4 minus 12 plus 8, which is 0. So the square root of 2 is a valid solution. Let's check the negative square root of 2. So negative root 2 squared, to the 4th. Watch out for those powers, they can get a little strange now. Minus 6 times the negative square root of 2 squared, plus 8. Well, by a similar argument, raising the negative square root of 2 to the 4th is going to give us 4. And raising the negative to the 4th, an even power, is going to make it positive. So we still get 4. Squaring the negative here in the second term and squaring 2 is still going to give us 2 plus 8. And we saw that this is exactly 0. So checking the positives and the negatives, the process will look very similar. Now, we'll do the same kind of thing. We'll check x equals negative 2. So negative 2 to the 4th minus 6 times negative 2 squared plus 8. Now we can work with nicer numbers here. If I raise negative 2 to the 4th power, the negative is going to cancel, being raised to an even power. And 2 to the 4th would be 2 times 2 times 2 times 2, which is 16. Similarly, if I square negative 2, the negative will cancel and I'll just get 4 there. And finally, 16 minus 24 plus 8 is exactly 0. I'll let you check x equals positive 2, but be aware, your process is going to look very similar to when we checked negative 2. Our solution set should work out.